I am Meliha.
I'm Leyla.
Are you ready to
Dive deeper into this board.
Nuclear physics is the study of atomic nuclei, their constituents and the interactions that hold them together. Nuclear energy is a form of energy released from the nucleus, the core of atoms, made up of protons and neutrons. This source of energy can be produced in two ways, fission and fusion.
Fission occurs when a neutron slams into a larger atom, forcing it to excite and split into two smaller atoms. When each atom splits, a tremendous amount of energy is released. Uranium and plutonium are most commonly used for fission reactions in nuclear power reactors.
But there are some disadvantages of fission. Like fossil fuels, nuclear fuels used for fission, such as uranium ore, are non-renewable energy resources since supplies will not last forever. Besides this, radioactive waste is extremely dangerous and long-lasting.
In some cases, the waste is stored deep underground and must be kept for tens of thousands of years, and it can weaponize. Also, it can cause accidents like in Ukraine and Japan.
Fission occurs when two atoms slam together to form a heavy atom, like when two hydrogen atoms fuse to form one helium atom. This is the same process that powers the sun and creates huge amounts of energy. It also doesn't produce highly radioactive fission products.
But fusion is difficult to sustain for long periods of time because of the tremendous amount of pressure and temperature needed to join the nuclei together.
One recognized drawback of fusion energy is neutron radiation damage to exposed materials. From here, we can understand that neutron waste is radioactive and this process is costly. But what if a neutron fusion is possible?
It is possible with laser boron fusion. There is a research team named HP11 working on this project, and their ideas could be the future of the nuclear energy. Hydrogen boron 11 fusion energy is developing fusion as a safe, green baseload power source. The main idea in this project is to use lasers instead of neutrons to initiate fusion, and this is possible with boron elements.
Boron is plentiful and safe. It's non-radioactive. It creates the least waste of all approaches to fusion and bears a dramatically smaller environmental footprint compared to gas, solar, nuclear, wind, or coal. It cannot be weaponized. As a fuel, it can be deployed in any country. Nuclear energy offers the possibility of unlimited, risk-free, zero-carbon waste of energy for the foreseeable future of mankind.
11 Energy deploys a laser system that combines thousands of commercial lasers to achieve required energy levels. This approach maximizes resiliency while creating energy and cost efficiencies.
The HP11 energy research focuses on using a highly targeted proton beam to ignite a hotspot in dynamically compressed boron fuel. That leads to a propagating high-gaining burn of the fuel. And this research harnesses the energy released to drive a power plant. It's based on that.
The hydrogen-boron fusion reaction creates 3 helium ions and releases energy. The reaction propagates through compressed fusion fuel.
The research team aimed to provide the safest, most permanent, and most environmentally friendly electricity on the grid.
This HP11 project we are talking about is just a prototype for now, but developers have come a long way in this regard and are now trying to bring it to life.